Today we have with us Ms. Srashti Goyal from the International Center for Theoretical Sciences, Bangalore, where she's doing her PhD on gravitational waves under the guidance of Professor Ajit.
A person who is moving on a spaceship with the acceleration upwards as 9.8 meter per second square would feel the same weight as the person who is sitting on the earth. For the moving frame, there would be time dilation and the length contraction, which is Einstein's field equation, in which we see that on the left hand side is the curvature of the space-time, and on the right hand side is the energy and momentum. Further, we were seeing some disappearance of the stars. What was happening is, as soon as the stars get near to the black holes were eating them up. What we ultimately get is that the strain would be of the order of 10 power minus 21. Now, this makes observing gravitational waves directly very challenging. Finally, in 2015, there was a first direct detection of gravitational waves made by the two LIGO observatories. What is done to detect the signals is the following. So from GR, we have the waveforms of the binary mergers. And what is done to the individual chunks of data, these waveforms are a match to the individual chunks of data. And whenever the match is greater than some threshold, we say that we have detected an event. What's done is we take the data and divide it into two parts. One is before the merger and one is after the merger, like from merger and the ring down. And we estimate the mass and spin of the final black hole. And see whether the estimations overlap with each other well or not. There are some massive graviton theories, and which would predict like a dispersion relation, like lambda is equal to h by mv. In the vector xy mode, we'll see that it's the oscillation direction is same as the direction of the propagational wave, and it would move in such something like this. So here we see that data at each of the detector can be written as some matrix times the individual polarizations of the gravitational wave. Gravitational lensing is bending of light due to a gravitational pull from the massive object. Further, there can also be weak lensing, which is where the wave optics limit applies, and diffraction and all those phenomena happen. And this would happen for the a little less massive lens. We discussed for the micro lensing, there would be sudden bump in the luminosity as the lens comes in between the line of sight. As you can see from this plot here, the base factors for the lensed events are higher than the unlensed events. Unlike the strong lensing, where we just have a magnification factor, there would be frequency dependent modulation in the waveform, which would essentially deform the waveform. So they have operations for which they can extract features given the images. And further, they have a few classification layers in the end, which gives us the desired outputs. They tell the probability of the event happening in each of the sky location bin. Further, as LIGO, I should mention that as LIGO India and 𝐶AGRA joins the network, we would be able to detect more events which are like BNS or NSBH, that is neutron star binaries or neutron star black hole binaries. So this is the AstroRel group at ICTS. We have a nice lively environment here for doing research. And this is my institute, ICTS, and I also would like to thank LSC, which is LIGO Scientific Collaboration.
What is the need of pre-inspirational data in IMAT test? In spiral data, sorry.
In spiral data. So what we are checking is for the IMR test. We are checking that whether the in spiral data and the merger ring down data are essentially consistent with the gravitational waveform that we expect to come out from GR. Now, to what is measured, that from the in spiral data we are measuring the final black holes parameters, and for that we not only require the in spiral data, but we also require some map which is or let's say some equations which map the initial black hole parameters to the final black hole parameters. And for the consistency check, we check whether both of these chunks of data, or both the parts of the data, is indicating whether our formulas or whether the waveform that we are using is. if you want to join in gravitational waves, I would say what's prerequisite is, of course, is general relativity and a little bit theory of gravitational waves, which you can find online. But right now it's more using working with data, so you really need to be comfortable with using computers and coding and so on. And yeah, and further I would say that I recommend this to, I don't know, all of my friends, that if you really want to get into PhD, then make sure that you're interested in research and you have done at least one research project.
So if you're a researcher or if you're interested in research, you have a lot of options available in our platform. You can be part of our live webinar session. You can also publish semi-technical research blogs, and also you can be a part of our research workshops. So there are a lot of options available. All you need to do is to put a message in our Facebook page or DM me or Anirudh, or also you can check our website out, www.researcheronweb.com, where you will find a lot of visual content, blogs, webinars, workshops happening here and there.